Hello everyone, and today I'm back with another video and we're going to be talking about homeostasis. So homeostasis is like a fancy word for maintaining equilibrium, but before I get into like the mechanisms of positive and negative feedback, I just wanted to say please follow me here and on YouTube. So if you go on this page and you go to the top, click YouTube and click subscribe, and that's going to help me out. It takes time to create this content, to make these pictures, to make it all like cute and color coded, so that way it's gonna help facilitate your learning. So please follow, so that way my effort does not go in vain. Also on YouTube, I have everything by class, so like organic chemistry, general chemistry, anatomy and physiology, etc. So go check that out. So jumping back, so homeostasis is maintaining equilibrium. What do I mean by that? So your body, for example, if we talk about body temperature, if you're like at a normal temperature, right? If you get too hot, what does your body do? It's going to sweat, right? And then you're going to go back to your normal. If you get too cold, you're going to shiver, and then it's going to bring you back to your original heat. So homeostasis are the ways that your body keeps itself, homeostasis itself is being in equilibrium, or, being at a normal state. But homeostatic mechanisms are what keep your body in check. What does your body do to bring itself back to normal? So I'm going to give you two examples. One is negative feedback, one is positive feedback. But before I can kind of tell you how this feedback loop works, there are some words we have to go over as a team, okay? So stimulus. What is stimulus? It's what affects you. So for example, let's say that I put my hand on the stove and the stove is on. That's hot, right? It's going to tell my brain, get your hand off the stove. This is burning you. So that heat or burning sensation is going to be the stimulus, right? My receptors are what is going to say, hey, I feel hot. This is feeling hot. It detects that change. The control center is your brain. Your brain is like, hey, what the heck? Like, it's burning. I'm burning right now. I'm going to tell my muscle, my hand, move, get off, like, take your hand off that stove. The effector is the actual muscle or gland that does it. So the muscle moving and taking my hand off. My response is taking the hand off, actually. So the effector would be the muscle moving my hand, and the response is taking it off and no longer feeling that heat. So let's do another example of negative feedback. So body temperature is a perfect example. So right now I'm going to be talking about being hot, but being cold would be the same. It would just be, instead of producing sweat, you would shiver. So let's do it. Let's say you go outside and it's 95 degrees, hot Houston weather, and you get super hot. So then the temperature increased in the environment. Then your receptors on your skin, they are going to detect that heat. They're going to detect the change, and they're going to tell your brain, I'm hot. Your brain is going to be like, dang, it is hot outside. What am I going to do about this? And so then it's like, well, I have sweat glands, so I'm going to tell the sweat glands to produce sweat. Then the effectors are your sweat glands. They produce sweat. And then your body responds by producing the sweat, and it cools down. Because obviously if you produce sweat, that cools down your body. That's why when it's hot and you shower, you feel so good, because the cold water brings that heat back down, right? And you go back to normal. That would be an example of negative feedback. And notice that negative feedback is not amplifying the response. It's quite the opposite. It is doing the opposite. So to bring back yourself to normal. Positive feedback, on the other hand, it's going to amplify that response. What is positive feedback? So for example, pregnant women, right? So when you're pregnant and you're going to have your baby, what's going to happen? Well, your brain is going to release oxytocin, which is the love hormone, okay? But in this case, we're not talking about love. We're talking about, well, obviously you love your baby, but we're talking about how oxytocin makes, stimulates the uterus to contract and push the baby out, okay? So what happens? Let's say you're already pushing the baby. So you already have oxytocin, right? So you're going to feel your cervix stretch. Well, maybe not you if you're a male, but I mean, women feel that. And then when they feel the cervix stretching, that's going to be the receptor. They're like, I feel this stretching. It's going to tell the brain, hey, I'm stretching. My cervix is stretching. So then the brain is going to say, well, the baby needs to get out. I'm going to release oxytocin. It tells the pituitary, release the oxytocin or release more oxytocin. Then the effectors is going to be the pituitary gland. The pituitary gland is going to release oxytocin into the bloodstream. Then the oxytocin is going to stimulate the uterus to contract even more and push the baby out. And this is going to continue. It's a positive feedback loop. This amplifies the response. More oxytocin released, more contractions, more stretching, then again goes to the brain, more oxytocin. That's why it's called positive feedback, because it amplifies the response. And an example would be, for example, contractions like we just talked about, but it could also be hearing. And so if you like this video, please follow me here and on YouTube, and thanks again for watching.